Hey everybody! The purpose of this video is to give you some solutions to the exponential regression quiz, this is the one on financial compounding interest. I'm using the Johnson & Johnson stock, which is when I googled it a couple days ago, it was a 3.6% return annually. So the point is to understand how this is exponential, why it's exponential, and also how it applies to finances. Hopefully at some point in your life you're going to care enough about this to throw some money into a bank account that accrues some interest, whether it's a bank account, a stock account, a CD, a money market, whatever. If that doesn't make any sense to you, maybe you take a business class or two. Anyway, the first question says, how can it be if the interest rate, the rate, is at 3.6%? And that's the same. I'm saying assume it stays the same year after year after year, 3.6%. How can it be that you earn more interest in dollars each year if your interest rate is staying the same? I mean, it seems like you should maybe make the same amount of interest each year. And the difference is this is not a linear model. In a linear model, that's exactly what would happen. So for example, if you were earning 3.6 more dollars per year, then after 2 years you'd make 7.2, and after 3 years you'd make 10.8, and you would actually increase linearly. But that's not what's going on. What's going on is your base amount is actually changing. Your base amount is actually changing. So for example, I gave you the table on the quiz so you can look at that if you need a concrete. In the first year you put $1,000 in. Okay, after the $1,000 is in, the next year you keep that $1,000, but you add to that $1,000 an additional $3.60, which is your interest, $36, I was off by a decimal place. $36, which is 3.6% of that 1,000. So now, the next year, the mathematics doesn't know that you started with 1,000. The mathematics is going to start over with 1,036. So you're going to apply 3.6 not just to 1,000, but also to the 1,036. So that's why you earn more each year. The interest rate stays exactly the same. So that's the simple, quick and easy answer to that one. And then eventually you have a model here that you work through, and the model ends up being, the amount in that account after n years. I think I used the variable n. And this is all, we walk through all of this in the quiz, is the 1,000 times 1.036 to the n power. So the next question is, after 10 years, how much money are you going to make? And after 10 years, all you're going to do is change n to 10, so you end up with $1,000, 1.036 to the nth power. There's 10th power, excuse me, rhymed with nth. And then you just crunch that out. I crunched it out and I got about 1,424 bucks. So 1,424 bucks. Beautiful. It's absolutely beautiful. You picked up your initial investment was 1,000, and over the course of 10 years you picked up an additional 424. So you can think about that. It can't be linear, because if it were linear, 3.6% of 1,000 is 36. 36 times 10 is 360. But you've got a lot more than that in your account. And of course, the more you put in the beginning, the more you're going to have here. If you put in 10,000, you'd have 4,240 more at the end of 10 years. So that's the idea of compounding interest. And then this amount, of course, goes in the 11th year, and that becomes the new base, and you take 3.6% of that amount and you keep going. So that's question number 2. Question number 3 asks, how long will it take our investment to double? And I gave you a little hint on that one. Put this one in a little box here. The hint is you can just do it as an intersection. The equation that you need to solve, if you're interested in the equation, the equation that you need to solve is, okay, you want it to get to $2,000. How long will it take? Well, that variable is that one right there. Is that one right there. So there are other ways to solve this, for sure, and I'll actually show. I'll make a second video. Well, we'll do it at the end of this one. You can just hit stop if you don't want to see the mathematical, algebraic way of doing it. But the way I explained to you guys how to do it in the quiz, if you wanted another way of looking at it was just to simply graph and create a system. You know, let this and this both equal y, and then see what happens from there. So when you actually graph and intersect, I believe you end up getting n is around 20 years. It's around 20 years. And like I said, at the very end of the quiz, we'll hit pause if you want, or stop, and I'll show you the mathematical way of crunching that number. You still require technology to get the result. It's just you can do it without a graph. You can actually do it equationally. Most students, I'm guessing, didn't have a pre-calculus course before Math 105, so I won't show it to you right now. So that's your solution for how long it would take to double from 1,000 to 2,000. The next question is Google the rule of 72 and explain how it relates to this previous answer. And this is a cool one. And again, I don't want to get into too much of where the 72 comes from because it's actually closer to 69. I'll come back to that in a second. But 72 is a convenient number to use. The rule of 72 says that if you take the number 72, and divide it by the interest rate, as a whole number, not as a decimal, but as a whole number. So in this case, 3.6%. That will give you the approximate time it takes the investment to double. Actually, it's not approximately equal. It's actually equal to exactly 20 years. Now, the reason this works is not trivial. It's based on something called logarithms, which, if you want to let the video play to the end, we'll show you how to use logarithms to solve this equation up here. But that's the rule of 72. You take the number 72, divide it by the interest rate as a decimal, or as a percent, not as a decimal, but as a percent, its percentage form without the percentage symbol. And that'll tell you how long it takes the investment to double, approximately. So about 20 years, which agrees perfectly with what you did up here, because it took you about 20 years to double, and that's how they're related to each other. Okay. If you're happy with those solutions, you can press stop right now. If you want to see an algebraic solution of that equation and also a partial explanation of why this all works over here, I'll keep going for you if you want. So I'm going to grab my eraser. Those of you that are interested, we'll see you in a couple seconds after we come back. Oh, hi. There's like 2 of you out there. So anyway, to solve this equation manually, at least more manually than graphically, you have to isolate the variable n. So if you think back to everything you learned about algebra, you want to get everything to this side that you can. So you can start with the 1,000. So you can divide 2,000 by 1,000, you get 2. So you got 2 equals 1.036 to the nth power, and you're good so far. Now, right now, at this point in time, you need to basically crunch through this and solve this manually. So the way you do that is you do something called you take a logarithm. Now, a logarithm, if you've never seen a log before, again, press stop on this video. If you want to know what it is, go Google it, or come see me in the office. That's totally fine too. Quick and easy definition of a logarithm is it's an exponent. So the idea is it's the inverting function of the exponential function, and it asks you a question. Now that's the quick and easy answer, that a logarithm is essentially an exponent. It's the invertible function or the inverse function of an exponential function. Since it's the inverse function, it's the way to get that out of the exponent and down to the working line. So what you do is you take logarithms of both sides, and then you use, there's a rule of logarithms called something which I've now forgotten that allows you to bring this down in front. So you got the natural log of 2 equals n times the natural log of 1.036, and so forth and so on. And then you can solve this equation, because now this is actually a linear equation. This was an exponential equation, which is the whole point of the quiz, but now it's linear. And since it's linear, you can just divide by this constant, and you get the natural log of 2 over the natural log of 1.036 equals n, and that's the number of years it's going to take to double. Now at this point in time, if you're happy with that, you would then just run this divided by this in your calculating machines, whether it's a calculator, whether it's a computer, whether it's Google, anything you want to do, and then you're done, and you're absolutely done. If you want to go further than that, and that's completely fine if you want to, you can use laws of logarithms to extend out and get the rule of 72 from this. So in other words, you can actually derive the rule of 72 from this relationship. The natural log of 2, if I remember correctly, is about 0.69. And 0.69, if I remember correctly, is, I believe, where the 72 comes from if they call. The reason they use 72 and not 69 is a lot more numbers divide into 72 than 69. If you think about the prime factorization of 72, it's 2, 3, 4, 6, 8, 9, up to 72, and there's a bunch of numbers in there, where 69 is only divisible by 3 and 9 and no, not even 9. So there's not many numbers to divide into it. So the reason we use 72 is it's got more factors, it's easier to use, and you don't get too far away from this natural log of 2 number that it truly mathematically is. That's why if you do this, you don't get exactly 20. I think this is actually closer to 19 and a half, but it rounds to 20 as far as a whole number. If you want anything more than that, if you want to see the derivation of the rule of 72 down to this, where this, how this leads to this, come on by the office anytime you want to. Be more than happy to sit down with you and work you through it. But I hope the rest of the video helped you get through the quiz.